our group went with a language detection model. We're Mohak's group, Curious Caterpillars. I'm Nicole.
Hi, I'm Hanzhen.
I'm Eric, and I don't know where Evan's gone. I think his mic might be broken. But
oh, sorry, I was muted.
Yeah. Okay.
Okay. Yeah. We have like a quick trailer. It's pretty dramatic, but it's not. Yeah. Could you guys hear the audio, by the way?
Nope.
You couldn't? Okay, it's okay. Just imagine really dramatic, like piano music. All right. Yeah.
All right. So the initial idea for our project was to create a computer vision model that would be able to recognize a language and basically say what language it was. And our original goal was to be able to differentiate between 14 languages, which we ended up reducing to 5 due to data and training limits. Basically, the steps we took were to first get a lot of images in different languages through online datasets, use RoboFlow to clean and label that data, put the data into the model and trainers, deploy the model, and also leave time to test the model and evaluate the results through charts and graphs. So while collecting and labeling our data, we struggled with finding good data sets because some were just like very pixelated, or maybe the language wasn't exactly clear, like as seen in the pictures. And lots of websites also required like quotas or like forms you fill out to get the data sets, which we never heard back from. So in the end, we were able to find good data sets for Arabic, Tamil, Gujarati, Chinese, and Thai.
Yep. Okay, so for the actual model training, we use the ResNet 50. It's a pre-trained model for image classification. And then we use the linear activation function with one like fully connected layer in addition to the model's like backbone layers. And for the ResNet 50, it has like 50 backbone layers, hence the name. So that would leave us with 51 layers in our model. And we started with 10 epochs, but we increased to 15 for like a faster runtime. And then we just stayed at 15 because we didn't want to like overtrain. Our final testing accuracy was 84.88%, which you can see like right here. Yeah. And then for our loss and accuracy plots, so you can see that our testing loss actually increases, but it wasn't by a significant margin, so we didn't worry about that too much. And then testing accuracy evens out over the epochs. So you can see like some slight variation here, like ups and downs, but then it gradually like evens out. So yeah.
Yeah. Okay. So I'm Eric. I was the front end and back end developer for this project. So for the front end, we ended up using a React, and for the back end, we ended up using Flask built off of Python. The reason why we used React was because we could have used Gradio, but I feel like React would give us more expandability if we ever decide to expand our website in the future. And Flask, because it's ideal, it's more ideal than what I thought was a really good backend solution already, Node.js. It's more ideal for what we're trying to do. We with Hugging Face as well, like when we implemented our model into our project, it didn't really work the first time. So we decided to scratch that and just do the model locally directly on the website. So it's not really like online, like you can't really access it online. It doesn't really work, unfortunately.
Okay.
We had quite a lot of roadblocks in our project. First, it was the datasets. Some of our images are poorly cropped, and we also had issues where some images were classified as like more than one language. And then during our first dataset, we realized some like the test dataset did not include like a certain class of images. So yeah, like we had to like fix our dataset like 2 or 3 times. Next slide. And then during the model training, it was also like pretty confusing. We did on Google Colab. We had like formatting issues. We had problems converting like the images properly. And then like initially our model like keep predicting the same class for every single image. And it was like really like frustrating when it did that. And then also problems with figuring out the batch size and then a lot of errors. Yeah.
So with the front and back end, there were a couple of roadblocks that I could mention. The most prominent of which I already explained a little bit in detail, but trying to load the model into the back end was a really big struggle for us because by the time I started building the back end, we hadn't really gotten the model figured out yet, and it just became a worry for us that we were like, you know what, we're gonna do it locally. Also, we spent so much time trying to figure out like how the model works that like I didn't have time to really like work on the front end. So like it's a really lazy job. And with our backend code, it had all sorts of issues. Like it couldn't render the front end. It can't like, or it couldn't like predict for a while. Yeah, it was just a mess, but we eventually got it working. So that's great.
Okay. And then for our resources, we used Collab for the model and then VSC for the front end and back end. For debugging, we used ChatGPT, and then we tried to use Hugging Face for like an API, but that didn't end up working out. And then Hanzhen used Runway ML for the video. So, yep. Okay, and then for a quick demo, Eric, go for it.
Yeah, sure. Yeah, I didn't really get time to deploy either. So yeah, a really basic site. Unfortunately, I didn't get time to finish all of it. So this is the best I did with the limited amount of time I had. But basically, I just choose a file here. So this is a Chinese one. It returns Chinese. A little preview here in case you choose the wrong file. But like this is, I forget which one this was, honestly. It shows up correctly. And the last one, like basically it works all right for what it is.
Okay, thank you.